this episode of the Radio Astronomy Podcast, we got the chance to speak to UK astronaut Tim Peake about his new book, Swarm Rising, what life is like on the International Space Station, and the future of human spaceflight.
Hi, I'm Tim Peake. I'm an astronaut with the European Space Agency. I flew to the International Space Station in 2015 on a 6-month mission. Before that, I was a military test pilot. I spent 18 years in the British Army Air Corps.
Great, Tim. Thanks very much for speaking to me today. It's great to have you on the podcast.
Good to be here.
I was thinking it's actually 5 years since you finished your first stint on the ISS and you landed. I bet it doesn't feel like 5 years ago.
So, some days it feels like just yesterday. Some days it feels like an awful long time ago. But no, I mean, the memories of spaceflight are clearly very, very fresh in my mind still, and still looking forward to what lies ahead in the future. So, and I'm working very much still very involved with the space agencies, both UK and ESA, and in collaborations of what we're doing for the future. So that keeps me very much tied to the work that I was doing with the space industry.
Fantastic, yeah. I mean, one of the reasons that our sort of paths have crossed is you've written quite a few books since you landed, and about your time on the ISS and photos from space and things like that. But now the book we're talking about today is Swarm Rising, which is sort of teen sci-fi, like science fiction, isn't it?
It is, absolutely. Yeah, it's a bit of a break from the normal, and I've really enjoyed it. It's been such a lot of fun, actually. And although it's a book for children, for teenagers, for young adults, it really tackles some interesting topics and some very adult topics, but in a really fun kind of action-packed way. I mean, we're looking at alien civilizations, traveling through space at the speed of light as digital information arriving on Earth. We're looking at environmental issues and touching on, the basics of what it means to be human and where we're going, where humanity is headed for in the future.
Yeah, it's really interesting. I mean, you also sort of teamed up with Steve Cole to write it, who's done a lot of Doctor Who fiction. How did that come about, and how did the what was the inspiration for writing the novel in the first place?
Well, working with Steve has just been incredible. I mean, he's such a professional. He's so fun to work with, and he's got such a brilliant imagination. So we have a huge amount of fun just having these Zoom calls where we bounce ideas off each other, and before we know it, we're just having a lot of fun creating these fun adventures. And that really was a pairing through my agency. They knew Steve, they knew the work he did, and thought, you two guys are going to be great together, and it has worked out really, really well. The inspiration from the book, it came from a number of things really over many, many years. I mean, I've got 2 young boys. They're now 12 and 9, and I love reading to them. I love kids' stories. I find them really exciting and interesting, and I like seeing what makes them tick. Two very different children, so different things make each one tick. And so I had this idea to write a children's novel, and the inspiration really came from various bits of information I was getting. I was going to briefings, I was listening to podcasts like The Infinite Monkey Cage, and hearing these things, neuroscientists talking about the potential for, could we really simulate a human brain? And actually, yes, if we had a supercomputer, we could. And Lord Martin Rees, Astronomer Royal, talking about if we're going to find intelligent life, it's very likely to be in the form of an electronic signal, coming from space. And kind of thinking, why not? Why didn't aliens do this millions and millions of years ago? And how would they have done it? And why would they have done it? What would they be doing about it? And let's create this incredible story around it. So the inspirations come from many different places.
So when you were writing the novel, did you sort of bounce ideas off your kids and sort of read extracts to them to get their feedback?
Yeah, very much so. We were living in Germany when I was based in Cologne there with the European Space Agency, and we had a camping trip to Slovenia, and there was a long drive. And so I thought, right, we've got 8 hours now to talk to the kids and get as much out of it. So I was running them through the storyline and finding out what they found interesting and fun and what they didn't and what they'd like to see. So they had a huge input to it.
And what about your sort of like your own inspiration? I mean, what were the sort of sci-fi novels that you enjoyed growing up and sort of still enjoy to this day, or indeed the sort of the TV and the movies that sort of played a part in the inspiration for the book?
I've always really enjoyed sci-fi, and people say when they talked about space movies, they say, "Don't you find it frustrating when they get so much wrong?" And I said, "No, because it's about the enjoyment, it's about entertainment, it's about letting your imagination run wild. And it might not be, scientifically correct, but that's not the point. The point is to have fun and be creative and think outside the box." So I've always loved, sci-fi movies. I grew up with Star Trek, Star Wars. I love that kind of thing. Really, this is just an extension of that, is just allowing my imagination to run wild.
Are you a Doctor Who fan? Was that something that sort of drew you to working with people?
A huge Doctor Who fan, yes. Yeah, I mean, Tom Baker was the Doctor Who when I was growing up, but I've loved every Doctor Who since, and thankfully, so do my boys. So, it's always a pleasure to sit down with them and watch Doctor Who even today.
I was really interested also in Swarm Rising with the sort of ecological focus and the climate change. It's sort of also about the sort of fragility of Earth, really, isn't it?
It very much is. I mean, that's the underlying theme. And again, when he's talking about inspiration, some of it comes from my thoughts when I was out on a spacewalk and kind of processing what it means to be human, looking back on planet Earth, and that sort of contradiction between, on the one hand, feeling tiny and insignificant when you're surrounded by the vastness of the universe in every direction, and you just think, yeah, really, we are just, very, very small. And then think, well, actually, we're not. We are the universe. The universe created us from neutron stars, from supernova, from 13.8 billion years of universal evolution. And we are complex organisms that have a consciousness and can now think about the universe, think about our place. And that makes us incredibly special. We may well not be the only life form in the universe. I don't think so. I think there's billions of life forms. But at the moment, that makes us really special. And so it is that kind of feeling of, well, Earth is a cradle of life. It's one of the locations in the universe where life can flourish, and that makes Earth really important. And Earth is something to be protected and nurtured for the remainder of its life, because it has this potential to generate life and to have life forms evolve. And so that's what the swarm's doing. They're interested in the planet. They're not so much interested in the humans. That's kind of a little bit interesting for them, but Earth is more interesting. It's a cradle of life within the universe.
Yeah, I have heard lots of sort of astronauts who've been in the ISS talking about that and sort of looking down on Earth and sort of realizing that, I suppose things like national boundaries and all these and sort of the names we give to countries and continents, that must just all sort of melt away, does it, when you're just looking at the blue globe?
It does. It really puts it into perspective. You just see and also this, the difference between day and night. In day, there's no signs of human habitation. So you get this impression of what Earth has looked like for billions of years. And then nighttime comes along and it's like, wow, there's signs of human life everywhere. Cities, towns, motorways, lights at sea, fishing vessels. So you get this, again, contradiction of what the planet might look like with no signs of human habitation at all. And you do just realize that we're all sharing the same atmosphere. We're just one species living on one planet, and you don't see any borders. Absolutely. It gives you a very different perspective of the planet.
Yeah. And also, I was also going to ask you about the actual physical experience of doing a spacewalk. What was it actually like? Because presumably there's no sort of up or down. Like Earth could be above you, or it could be below you, or it could be beside you. What's it actually like? Actually doing that EVA?
And it's really interesting because you get very used to that inside the space station. And within just a couple of weeks, you can be flinging yourself around in every module, upside down, all over the place. And your brain is just able to really switch and work that out. Going outside on a spacewalk is completely different. And because you're in this new environment and you're so exposed, it's actually very hard for your brain to work out where you are. And it's very easy for astronauts to become, lost out there and to become disorientated. We have black arrows all over the space station on the outside with arrows pointing back to the airlock. So, if you get yourself a little bit unsure of your position or circumstance, which sounds strange. In the daytime, of course, you've always always got the Earth to look at. But at nighttime over the Pacific, it's pitch black. You're surrounded just by a small pool of light from your helmet lights. That's all you've got. And space looks very dark and scary, and the space station's a very big place, the size of a football pitch. So, yeah, you can get a little bit disorientated out there.
But it must also be like just completely psychologically and physically exhausting doing a 4.5 hour spacewalk.
It is. I mean, it's an environment where you have to concentrate more than anything else I've done in my life. Even on high risk flight trials, there'll be periods where you have very, very intense moments of concentration. But on a spacewalk, you're having to maintain that level of concentration for hours at a time, and at the same time, you're trying to think ahead. You're trying to make sure everything goes well, but you cannot lose focus on what you're doing right now. And also, you're keeping half an eye on what your buddy is doing and where they are, and listening to all the communications going on. So this ability to have situational awareness and concentration, these are skills that are tested right back at astronaut selection. On the very first day of astronaut selection, these are the kind of skills that they're testing for. And spacewalking is a prime example where we might need to use those skills.
Did you have any sort of hair-raising moments where you sweat got in your eye or anything like that?
So yeah, there are times when you notice you're working a bit hard and you're starting to sweat. That's where you've got to really regulate your body temperature, because you cannot afford to have sweat dripping in your eye and stuff like that. And that certainly happened in one eye. I started to get a little bit of sweat in. You're like, oh no, because that's a nightmare. Then your eye starts watering and it escalates. And also I had one moment where, at the very end of the spacewalk, where Tim Copra had to go in first, I switched over to be EV1 because he had water coming into his helmet and had to terminate it. And there was a moment there where I wasn't sure that I'd clipped on. I pushed away from the airlock because I needed to use both hands. And for a split second, I just thought, did I clip on? And it was the worst moment in my life, because I was only 2 feet away from the hatch, but I was floating in space. And I just thought, if I didn't clip on, then we're in big trouble. Thankfully, I'd clipped on. But it just goes to show you could never lose concentration.
Absolutely. I mean, it must just... Does it feel like that the whole time you're on the ISS? Do you ever really relax? Even when you're inside the space station?
I don't think you ever really relax, and that's important not to really. I think you've always got to maintain awareness of where you are, because the moment that piece of debris strikes and the space station starts depressurizing, you've got to be able to respond instantly. Or ammonia comes into the atmosphere, you need to know exactly where the nearest breathing apparatus is. And so that places a kind of low-level stress on you for the entire 6 months. So no, I don't think you do ever switch off or relax. But you've got to have periods where you recharge your batteries. At the weekends, we drop the tempo. During the week, we're working extremely hard. But you've always got to have something in the tank so that you can react if something goes wrong. Yeah,
I mean, when you were up there, we at Skynet Magazine, we had great fun sort of keeping up to date with what you were up to, and some of the stuff that you did was really, really cool. Like I remember you watching a Six Nations game, and you ran the London Marathon, and then there was the being chased by Scott Kelly in the gorilla spacesuit, and it really made it clear sort of how far we've come from the sort of cramped conditions of the Apollo modules, where everything was really sort of cramped, but now you can actually sort of spread out and have fun, can't you?
Absolutely. It's about normalizing the environment, and that's important for us as astronauts so that you can work effectively. You can't spend 6 months kind of in awe and wonder and being overwhelmed by your circumstances. So we try and normalize it as much as possible, and that means relaxing. That means having a fun and enjoying your time up there. And I think what helps today is that we have such great communications. Is people can now see it. We've got video downlinks. We've got internet. We've got Wi-Fi, and people can share in the experience. And we're getting to the point where more people are going to experience space, which is fantastic. So no, I think it's really exciting as to where we are currently on the space station and where we're going in the future.
What about the serious work that you were doing up there? The science experiments. What was that? What were your duties as far as that was concerned?
Yeah, but it's, we are responsible for running the ISS as a microgravity laboratory, as the astronauts. That's our job, is to try and get through as many experiments as possible to keep things running efficiently and smoothly. So in any one day, we might be touching 10 different experiments that people have spent years and years working on. And our role is to make sure that they all run as accurately and as correctly as possible. So it can be quite stressful. There's lots of following procedures, and you have to be really careful what you're doing. You have to work fast, but you have to work accurately. You also, it's fun to know what you're doing, so you have to read up about the experiments to understand the implications of if things don't go right. So it's such a rewarding environment to work in, though, because one minute you might be doing some protein crystal growth experiment that is going to create new drugs that's going to help people with motor neuron disease or Parkinson's, and then the next minute you're in the airlock doing an experiment on airway inflammation, and that's going to help asthma sufferers. Or you might be doing material science where you're creating new metal alloys that are going to make, potentially new aircraft turbine blades lighter and stronger and more efficient. Or you're developing new sustainable systems for breathing, carbon dioxide scrubbing, water purification and production. So every day you're just touching these things that you think, this is fantastic. This is having huge benefit for people back on Earth. And it's a real privilege to work in that environment.
Yeah, definitely. It also sort of makes you think that a lot of the kids who are sort of reading Swarm Rising and your other books and getting interested, it's probably sort of very inspiring to them and makes them want to get involved. I mean, in the space program, and be astronauts and space engineers and things like that. What sort of advice would you give? Presumably, you have to sort of study science and maths, and maybe eventually at some point learn a bit of Russian.
Yeah, I mean, that's the great thing is when I come back and I get the opportunity to talk to students and children and try and give them some advice for the future. And space is something that most people find really fascinating, which is wonderful. And so if people want to get involved in science and tech and engineering, then I really encourage that, not just from a point of view of the potential for working in the space industry, but as we all know, we are just surrounded by technology right now, and the pace of development is phenomenal. And it doesn't matter if you're going to have a career in science or if you're going to go into art or literature or drama, you are going to be working with technology. So if you study those subjects at school, you're really setting yourself up well for the future. You're giving yourself the maximum opportunity for being successful. But at the heart of everything, it's about, being passionate at what you do. So you've got to try and find out what it is that makes you click. And that's my biggest message is, find out what it is that you're passionate about. That's what you're going to be really good at.
Do you think that your own kids have sort of been inspired to follow in their father's footsteps?
I think my eldest might. He certainly loves the idea of becoming a pilot, and so I'm going to, obviously encourage him in that. My youngest is a great engineer, so he might go on to do something like that. But I'm also keen to just let them find their own way, try and expose them to as much as possible, and just try and encourage them to try things. I mean, as a kid, I bounced around doing all sorts of stuff before I kind of settled down and found out what it is that I like to do. And that's completely normal. Some people realize in their teens, some people realize in their 20s, some people don't realize until their 30s. The point is to try and just experience different things so you get a flavor of what it is you like to do.
Given your sort of all the knowledge and experience that you've built up through being an astronaut and being in the ISS, did you ever think about writing, fiction based on the ISS or based around spaceflight?
It's something I've enjoyed because I've enjoyed reading, fiction books and sci-fi books so much. So yes, absolutely. You get inspired by these environments. I've got plenty more ideas as to some great adult fiction stories that are going to be space based. And again, it's just an environment where you can really imagine, let your imagination run wild. And certainly Swarm Rising and the Swarm series of books has got hopefully a long future ahead because there's plenty more fun to be had with the Swarm.
So it's going to be a series. There's going to be like future installments.
Well, we've definitely got Swarm Enemy coming after Swarm Rising, and then watch this space.
Great. Yeah, just to go back to sort of life and working on the ISS, one of the things I always think is life on the ISS must be pretty cool, but the actual launching and landing, it must just be absolutely terrifying. I mean, maybe not for, obviously not for someone with your training and everything, but, for the average person, it would just be absolutely terrifying.
Well, yeah. If you went into it without any training, it would be terrifying, and it would be terrifying for anybody to do that. But that's part of what we do, is going into the centrifuge, building up those G forces, so we know what to expect. Training in the simulator. So that by the time we actually come to launch and re-entry, we pretty much know what it's going to be like. The interesting thing is the simulators don't give you all the kind of bangs and whistles of what's going on. And launch is exciting, but you expect that. And the centrifuge, gives you that experience. But re-entry is actually far more dynamic. There's pyrotechnic bolts being blown apart, the spacecraft's tumbling, parachutes opening faster than the speed of sound. The simulator doesn't give you any of that. So that is a really fun experience. And the night before coming back to Earth, Jeff Williams and my NASA crewmate on board, he kind of just said, right, I'm going to talk you through re-entry because, this is what you don't know. And it was great that he did that, because there were several points where, he said, if you're not expecting this, you'll think it's catastrophic. It's not. That's normal. So it's good. As astronauts, we talk to each other and we let people know what's going to happen.
I mean, there have been some amazing stories over the years, haven't there? Of like the one that sticks in the mind is Alexy Lanov, the first man to spacewalk, and he ended up obviously having a horrendous time getting through Earth's atmosphere and landing in the Siberian wilderness and fending off bears and all sort of stuff. Were you aware? Well, you obviously were aware of those stories, but were stories like that sort of in the back of your mind?
Well, yeah, and I had the huge privilege of meeting Alexei, and he actually waved us off from the Cosmodrome in Star City before heading down to Baikonur. And when we do our survival training in Russia, in the woods there in the wintertime, these are the reasons why we're doing it. And our instructors, go to length to explain to us where we could land and what could happen and how long it might take. So, yeah, we do get told those stories, and it puts a good emphasis on why we need to do all that training.
And then once you finally land, presumably your legs are like jelly. How long does it take to get back to normal?
Yeah, well, it's interesting because your muscles are still in quite good condition because we exercise so much on the space station. So you've got the strength. What you haven't got is you haven't got the balance and you haven't got core stability, because that's one area that we find really hard to exercise on the space station. But, you can stand up, okay, and you can walk, but you just feel a little unsteady on your feet. And certainly for me anyway, my vestibular system was messed up for a good 2 to 3 days. Where my head was spinning. It was really unpleasant to kind of move my head from side to side or to do this. Whole world was turning upside down. And I just think that's because, the whole brain is trying to get used to gravity again.
Yeah, I mean, I was speaking to a geneticist quite recently who had made the argument that we might need to do some sort of resequencing of human genes in order to be able to survive sort of long-term spaceflight to Mars and things like that. I mean, do you think that the science that we're doing on the ISS with regards to long duration of spaceflight is enough, or do you think that it is going to take something really drastic to enable the human body to survive long journeys?
I think we've got Mars nailed in terms of, I think, yeah. So, I mean, when I arrived on the space station, Scott Kelly, Misha Kornienko were 8 months into their year-long stay, in great shape, physically, psychologically. That's about the journey length to Mars, the maximum. They would have coped just fine going down to the surface of the planet. You might feel a little rough for the first couple of days, but certainly you're well enough to cope with setting up a habitation module, going through the basics of getting yourself into a survivable situation. So I think Mars is certainly within our capabilities with current technology. We have to get better at radiation protection in our spacecraft, but that's just a technical point to overcome. I think further exploration into the solar system, you're absolutely right. The problem is, of course, that the human body is brilliant. Our body is brilliant at adapting to new environments, and it tries to adapt to weightlessness far too well, and we're trying to stop that from happening if we want to go and work in a gravity environment. So, centrifuges on spacecraft for the future, for long duration missions, revolving sections that enable us to kind of maintain some sort of G environment, then that could be essential.
But what about the sort of the psychological impacts as well? Does that worry you?
I think it doesn't worry me because, we just need to make sure that we select people who are going to be able to cope with those environments and those circumstances. And we've built up a huge amount of expertise over the years in understanding the kind of psychological profile that is required for long duration spaceflight. It is going to be a factor. I mean, the last 2 weeks of my mission were very, very different because we had to close all the hatches. There was a risk of some fuel leaking and impacting on the hatches. So the space station suddenly became a very different place with all the hatches closed. You no longer have the view of Earth. You feel very isolated, very sort of self-contained. And that's going to be the case on a mission to Mars. And Earth is going to become just a small sort of speck of light in the night sky. So psychologically, it will be interesting. But I think that we have enough knowledge to be selecting the right people for the job.
Yeah, I was also wanting to get your thoughts on the prospect of creating a sort of a permanent human settlement on the moon. I mean, do you think that that's necessary? Do you think it's a good idea? And would your astronaut class be in line for being part of that mission?
Yeah, I do think it's the next logical step in our progression. I mean, there's also a strong argument for going straight to Mars as a destination that we want to go to. I think that, operations on the lunar surface, we're always going to be, that is such an obvious place for us to experiment, to live and work for long duration. And the moon has so much to offer in terms of knowledge of the solar system. It's this environment that's been exposed, and we've only scratched the surface really in terms of what the moon can offer in terms of the water at the poles, for example, the areas of permanent sunlight at the south pole around the craters. And so I think it's a natural location to de-risk future long duration missions, to go there, to set up habitation modules, to experiment with 3D printing techniques, inflatable or foldable habitation modules, to really get our surface operations very slick, very safe, before making the much longer transition to Mars, where we won't have the ability to have resupply missions.
Yeah, and I suppose all of this, the success of the ISS and the sort of future success of the Moon and Mars missions depends on the sort of international collaboration that has been fostered. And with regard to that, you do sort of think of the Apollo-Soyuz missions and the Russians and the Americans finally coming together, and then the Americans having to use the Soyuz and that becoming part of that collaboration. I just wanted to get your thoughts on the commercial crew program and the prospect of Americans once again launching from America. Do you think that the Americans and the Russians will lose that sense of sort of collaboration?
I don't think they'll lose that sense of collaboration. I think the collaborations will change, and I think it's going to be an interesting environment. But in terms of, that partnerships, we've obviously with the Artemis program, we're maintaining a strong partnership between NASA, ESA, JAXA, Canadian Space Agency, and we're working closely with our Russian colleagues on the International Space Station and future development so that everything's compatible. That's what you want, is compatibility. So even if different nations are doing different things or have different priorities or different objectives, we're all going to be working in that space environment. We all want the potential for collaboration in certain areas, and I think that we're going to see that over the years as we develop our exploration of the moon and as we go on for missions to Mars as well. And that relationship is also equal to commercial partnerships. The Artemis program will rely on SpaceX, on Blue Origin, for example, of delivering large components of either the surface habitation modules or potentially the gateway in orbit around the moon. And that partnership will continue as well. So I think it's going to be a really interesting and exciting environment, but we're going to have to see, that collaboration continue because, space is a tough and hostile environment. And if we don't work together, then nobody's going to succeed.
Yeah. And what are the implications of the commercial program for ESA astronauts?
Well, the commercial crew program is obviously essential because we now are flying on that. We've seen Thomas Pesquet launch aboard SpaceX. We have Matthias Maurer later this year who will launch on another SpaceX. And, a lot of our future European astronauts will be launching on the commercial crew program. There's still the possibility that we'll have Europeans launch on the Soyuz. And who knows, maybe Europe will decide that it's time to have our own access to space in terms of human space flight. So it's a key component, and it goes back to that whole collaboration. We're trying to, hand over low Earth orbit in some respects to commercial companies so that the space agencies can focus resources on deep space exploration.
Fantastic. I did just want to finish by sort of going back to Swarm Rising, because the sort of the ecological message of it is really, really important. And I wanted to get your thoughts on that, taking what we've learned about Earth and protecting Earth forward as we go to sort of potentially colonize, for want of a better word, Mars and the Moon, and sort of pristine, cosmic objects. Do you think there are lessons to be learned? And are you in any way worried about what humans might actually do to Mars when they get there?
I'm actually more encouraged now. I think that we've gone through this phase of our initial steps of exploration where we're just trying to achieve getting into space in the 60s and 70s. That was the goal. It was so hard. It was so difficult. And, the environmental impact wasn't at the forefront of people's minds. Now we've got over 500,000 pieces of space debris floating around in low Earth orbit, and people are really waking up to the fact that if we carry on like this, space will no longer become usable by humans. We will be surrounded by a cloud of debris that will actually stop us getting off our own planet, and it will stop commercial companies launching anything new into space, and then so there's a financial incentive as well as an ecological incentive to protect that environment, and we're now really seeing that amongst governments, amongst agencies, and amongst commercial companies. So I am quite optimistic that the technologies I'm seeing now in terms of clean fuels for rockets that can have really low carbon impact in terms of recovering pieces of debris, in terms of developing space tugs, space debris removal techniques, and clearing up the space environment and taking those messages forward. I mean, whenever we send a rover to Mars, for example, we spend a huge amount of effort in making sure that it is not going to contaminate that surface, that it is going to remain a pristine environment, and doing it in a sensible and clean, clever way. I think that we need to be a bit better on our regulation. At the moment, we're relying on agencies to do that and commercial companies to do that, but we don't really have any strict regulation in place. So I think that's an area that we need to focus on to make sure that we regulate the environment and we make sure companies adhere to it, individuals and agencies adhere to that.
Yeah, it's fascinating talking to you about all this stuff, and it does sort of give you sort of quite an optimistic view on the future for spaceflight. It's looking quite good at the moment, isn't it?
I think it is looking really good, absolutely. And I think we're going to see a really exciting 10 years in space. I was born in 1972, so I didn't get to see, humans walk on the moon. So I'm really excited about the prospect of watching humans, walk on the moon. Who knows, even getting the opportunity to do it myself. And hopefully in my lifetime as well, seeing humans land on Mars. I mean, that's going to be phenomenal. And I think as a species as well, it will really, open people's eyes up into, what we can achieve, what is possible, and also what is out there. And that's why, come back to Swarm Rising, that's why it's really exciting to write about that kind of thing, because it's about to come into people's, forefront of their minds once again.
Fantastic. Well, Tim, it's been great speaking to you today, and good luck with the book. I think it'll be out just as this sort of podcast goes out. So good luck with that, and good luck with all your future endeavors. Thanks for speaking to us today.
Thanks very much. Great talking to you.